All right, let's jump right in. We're about to explore a pretty wild idea that our entire planet, from the molten core all the way to the top of the atmosphere, works like one gigantic, self-charging, saltwater battery. Now, I know that's a huge concept to wrap your head around, so let's start with a simple question. What if all the complex systems that make our world tick, the tides, the magnetic field, even life itself, could all be explained with one single powerful analogy? And what if that analogy was this little thing, a simple saltwater flashlight? I know it seems totally impossible, right? A flashlight and a planet? But stick with me, because as we're about to see, the same basic principles that make this tiny lamp glow are actually scaled up to a planetary level, creating the very forces that make Earth a living world. So let's break this connection down. How on earth can we compare a tiny flashlight to an entire planet? Well, the answer is in the fundamental parts of any electrical circuit. First, let's look at our little model here. A saltwater flashlight is incredibly simple. You add salt water, that's your electrolyte, it lets the ions move around. You have two different metals, those are the electrodes, and they react in the salt water. This whole reaction creates a flow of electrons, an electric current, which is what makes the lamp light up. Super simple, right? Basic chemistry. Okay, now for the fun part. Let's map this idea directly onto planet Earth. That saltwater electrolyte, well, that's our oceans. The two metal electrodes, that's the planet's metallic core and its mineral-rich crust. The thing that keeps it all moving, that's the spin of the planet and the pull of the moon creating the tides. And the lamp, the light our planet gives off, that's the invisible but absolutely vital geomagnetic field. This is our roadmap for the rest of the way. Let's start at the very heart of our planetary battery, the engine running at the core. This is where it all begins. The key mechanism here has a pretty cool name, the geodynamo. Now, it sounds complicated, but the idea is just brilliant. It's basically a self-sustaining generator. If you have a moving, electrically conductive fluid, it can create and actually maintain its own magnetic field. So here's how it works on our planet. Earth's outer core is just this massive sea of liquid iron and nickel. As the planet spins, all that molten metal churns and flows. And because it's a conductor in motion, it generates these incredibly powerful electric currents. And here's the beautiful part. It's a feedback loop. Those very currents are what sustain and power up the magnetic field in the first place. There's a quote from the source material that just puts it perfectly. The core isn't just one piece of the battery. It's the central power source and the light bulb's filament all in one. It's where the glow that surrounds our entire planet comes from. All right, let's move out from the core to the next layer of this battery. We're talking about the vast conductive salt water of our oceans. And this is where the scale just becomes mind-boggling. The moon's gravity pulls on our oceans, creating the tides. This moves billions of tons of salt water, which, remember, is full of charged ions, making it a great electrical conductor. And it moves it straight through that magnetic field we just talked about, the one generated by the core. This process has a name. It's called magnetohydrodynamics. Basically, anytime you move a conductive liquid through a magnetic field, you generate an electric current. Think of it like Faraday's law of induction, but instead of a copper wire moving through the field, your conductor is the entire ocean. And the amount of energy we're talking about is just immense. The total current flowing through the oceans is measured in millions of amperes. That is a colossal amount of electrical energy, and it's all being generated by the simple, steady motion of the tides. But this circuit doesn't stop at the bottom of the ocean, not even close. It actually extends deep into the Earth's crust and then stretches all the way up into the sky, connecting everything together. It turns out the Earth's crust itself is electrically active. You've got these geological zones with different chemicals that act just like natural little battery cells. You've got tectonic plates sliding past each other that are basically giant moving electrodes. And get this, at deep-sea hydrothermal vents, there are microbes that literally plug into this circuit, getting their energy straight from the planet's electricity. And then we look up. The atmosphere forms the outer layer of this whole system. See, the Earth's surface has a net negative charge, while the ionosphere, way up there, has a positive charge. This creates a constant electrical field between the ground we're standing on and the sky above. How much of a field are we talking about? On average, about 300,000 volts. There's this constant electrical potential all around us. So the big question is, what keeps this massive global capacitor charged up? The answer, believe it or not, is thunderstorms. At any given moment, there are about 2,000 thunderstorms happening around the globe. And with every flash of lightning, they're constantly pumping negative charge upwards, acting like planetary battery chargers that maintain that voltage in the global electric circuit. So let's put all these pieces together. From the churning core, through the electric oceans in the crust, all the way up into the sky. What we have is one giant, interconnected, living circuit. And the elegance of it all is just captured perfectly in this quote. This isn't a simple one-way system, it's a massive feedback loop. The core's field drives ocean currents. Those currents induce electricity in the crust, and that connects to the atmospheric circuit. Everything is linked, everything reinforces everything else. And once you start to see the planet this way, you realize that so many natural wonders are just visible signs of this circuit at work. The auroras? That's the visible glow of the current entering our atmosphere near the poles. The planet's faint electromagnetic hum, what we call the Schumann resonances, that's literally the vibration of this global circuit. And even life itself is part of it, a living, breathing filament glowing inside this planetary lamp. And here's the best part. Unlike that flashlight in your hand, this battery never, ever runs down. It's constantly being recharged by these incredible perpetual energy sources: heat from the core, the gravitational pull of the moon, and energy from the sun. The parts, water, salt, minerals, they're all just endlessly recycled. All of this brings us to one final, really profound question. If our planet is this dynamic, interconnected electrical system, then what really is our world? It's so much more than just a rock floating in space. It's a lamp, and its fuel is constant motion, the spin of the planet and the pull of the tides. And its light? Well, its light is that invisible magnetic field that shields us, that guides animals, and that creates the fundamental architecture that allows life to exist in the first place. A planetary saltwater battery just humming with a current that runs through stone, sea, and sky.